The mole concept. The mole concept is a concept that every chemistry student should be familiar with. It is a very essential concept in chemistry calculations. We'll be talking about it today very briefly. The mole is a convenient unit of quantity of particles, and these particles refer to elementary particles we study in chemistry, such as atoms, electrons, formula units, ions, protons, neutrons, and so forth. These particles are affiliated with number of mole, as we are going to be seeing as this lecture progresses. But one thing we need to know is that just as in our everyday life, we need units of representation of what we use in day-to-day activities, and this unit include things like a dozen, a score, and a gross. This unit refer to a specific number of items, such as us saying a dozen refers to 12 items, a score 20 items, and a gross 144 items. A mole is 6.02 times 10 raised to power 23 particles. This is something we should take into consideration. It's a very important point. A mole is 6.02 times 10 raised to power 23 particles. This number is regarded as Avogadro's constant or Avogadro's number. That is 6.02 times 10 to the power 23 particles is regarded as our Avogadro's constant or Avogadro's number. And this is in honor of the Italian scientist Amedeo Avogadro. Now, the mole can be defined as the amount of a substance that contains Avogadro's number of particles. It is just like what I said earlier. It is something that can be likened to quantity of things, like a unit of quantification. So just like us saying a dozen of eggs is 12 eggs. Okay, 1 mole is equals to 6.02 times 10 to the power 23 particles. That is what the mole concept wants you to understand. So the unit of number of mole is mole. The unit of number of mole is mole. The unit of number of mole is mole. And number of mole can be represented by small letter n. It can be represented by small letter n over here. So one thing we should also find relevant is that, like I said, you have to understand mole concept for you to be able to participate in chemistry, in calculations in chemistry. And now, why is that? This is as a result of the fact that mole plays a central role in calculative chemistry or quantitative chemistry, as it has relationship with many parameters in chemistry. Mole has relationships with many parameters in chemistry, and these parameters include mass, volume, molar mass, concentration, and so forth. So mole is quite affiliated with a number of quantities in chemistry. So it is very important that we understand it. Now, some of the most important relationship that mole has with most of these parameters will be discussed about in this session. Now, we'll be moving to mole relationships now. Now, the relationship mole has with most of these parameters has some circumstances in which um, we are actually going to be utilizing these relationships when attempting calculations. Now, for example, circumstance number one, or let me just say scenario number one. In our calculation, when we have substances of a known mass, our number of mole is going to be equals to mass given all over molar mass. Now, our mass given is measured in the unit gram, while our molar mass of substance is measured in the unit gram per mole. If our mass is given in kilogram we know we have to convert it into gram, which is the basic unit of what? Our mass. Now, molar mass. Now, we know the molar mass of a substance is the sum total of the atomic masses of that substance. For example, when they give us H2O, which is water, and they tell us to look for the molar mass of water, we are going to sum the atomic masses of this. And what is the atomic mass of hydrogen? The atomic mass of hydrogen is 1. Now, in this case, we have two atoms of hydrogen. So we have to put that into consideration. That will be 1 times 2. Hydrogen has a molar mass of 1. But since we're having two atoms, going to be multiplied by 2. Plus, since molar mass is talking about the sum total. Oxygen. Oxygen is what? The atomic mass of oxygen is 16. So 1 times 2 gives us 2 plus oxygen, which is 16. The sum total is going to give us 18 gram per mole. This is the molar mass of H2O. Okay, now how do we get the unit gram per mole? We know it has been mentioned to us that number of mole is measured with the unit mole, and we all know mass is measured in gram. So how do we get the unit of molar mass? The unit of molar mass was simply gotten by let's just say we represented these parameters with their unit. For example, let's say number of moles is mole. The unit of number of mole is mole. So let's say representing these parameters with their unit, we have mole is equals to mass given. Our mass given, we know the unit of mass given as gram. So we did not know the unit of molar mass of substance. Well, I've given you already. But in case you want to get why it is gram per mole, you say, okay, we don't know the unit of molar mass here. Then what are we going to do? When you have something like this, mathematics, you cross multiply. So let's always know that there's going to be an invisible one here. And add the one. So what's going to happen? Our G multiplied by 1, our gram times 1, is going to give us gram is equals to, then our mole times, let's represent this unknown as X. So we don't know it as X. So this will be our X times our mole. Let's represent our multiplication with this dot. Then what happens? Our X is disturbed, our mole is disturbing this unknown. So what happens? We divide both sides by our mole to stop disturbing the unknown. Since it's the unknown we are looking for, divide both sides by our mole. Then when you divide both sides by our mole, we have X is equals to gram over mole. So this is gram per mole. It can be written like this, but mathematically, according to indices, we all know that when you have 1 over a, 1 over a is the same thing as a raised to power minus 1. So this g over mole can be written as g mole raised to power minus 1. So that is something we need to know as mathematics. As science students, we need to know mathematics and we need to understand indices. That's how we get our gram per mole. Okay, so moving on, we need to know that when we are given substances of known masses, this is the formula we are going to use. So in our question, when we have mass, we are always going, this formula is always going to surface most times. We are always going to use this to look for a number of moles or look for your mass. no, your mass will obviously be given. But this formula, when you have substances of no masses, utilize it. Now, the second formula for solutions. Now, when a solution is mentioned in your question, most times these things are usually mentioned in questions, but most students don't take note of it. Some people keep asking, okay, what formula am I supposed to use to arrive at my answer? Understand the question very well and you know the formula you are going to use. Now look at this now. When we have solutions, our number of mole is going to be equals to concentration times our volume. Now, using the same technique, you can use it to understand how we get mole per dm cube as our unit. We all know that the unit of volume is dm cube. So you need to know the unit of these things because most times in questions they won't tell you okay this value is for concentration, they won't tell you okay this value is for volume. But when you know the units, for example, when you see dm cube, you know they are talking about volume. When you see mole per dm cube, you know they are talking about concentration. And when you see mole, you know they are talking about number of moles. So sometimes even when you don't see the solution and you see something talking about concentration, something talking about volume and concentration and number of mole, you know this is the formula you are going to use. So when you see solutions, the formula for number of mole is number of mole is equals to concentration times volume. Very, very easy. When we start solving, you see examples and you see that no, there is nothing very hard about calculations in chemistry. Once you understand the mole concept, calculation starts becoming very, very less challenging for you. So moving to the next one, we have gases at STP. Now, when we say STP, we are talking about standard temperature and pressure. So gases at standard temperature and pressure. And we know standard temperature is 273 Kelvin. 273 Kelvin. And we know standard pressure is 760 millimeter mercury. Okay, so when any of these parameters are mentioned, we know we are talking about gases at STP. So that's for gases at STP, our number of mole is equals to the volume occupied, which is the same thing as volume. That is the volume occupied by the gas, still measured in dm cube as always, over 22.4. Now this 22.4 is a constant. It is a constant. So it is a number you need to know by heart. So when you're talking about gases for STP, this is volume over 22.4 dm cube per mole. So dm cube per mole. Oh, I'm sorry. dm cube doesn't have this. dm cube doesn't have. dm cube doesn't have this at all. Doesn't have this at all. Okay. I'm sorry for the mistake. So we can move on. dm cube doesn't have this minus sign in front of it. Okay, moving on. For an ideal gas. Now, number of mole for an ideal gas. Now, when an ideal gas is mentioned, this is the formula for you to use. And don't forget, number of mole can also be represented by a small n, by a lowercase n. So this n represents our number of mole, P represents our pressure. Now our pressure is measured in ATM. Our pressure is measured in ATM, while our V is our volume measured in dm cube as always. Then our R is our general gas constant. Our T is our temperature. Our temperature is always measured in Kelvin. Then our general gas constant, because it is a constant, has a value, and the value of our general constant is 0.0821, and the unit is atm cube a mole per Kelvin. So atm cube per mole per Kelvin. So when you see an a question telling you to look for the number of mole of an ideal gas, you increase these parameters and you get your answer. So pressure measured in atm, volume, general gas constant, and temperature. Now, one thing we need to know is that most of you are very conversant with the unit of pressure as millimeter mercury. But in case you want to convert to atm, always know that 760 millimeter mercury is equals to 1 atm. So for example, if they give you, okay, convert, let's say, convert 50 millimeter mercury, which is a unit of pressure, 50 millimeter mercury, convert it to atm. It's very simple. What you just do, you just come, just say, okay, 760 millimeter mercury is equals to 1 atm. So 50 millimeter mercury is going to be equals to what atm? You put it underneath it or on top of it like this, then you cross multiply, cross multiply. Then when you cross multiply, 50 millimeter mercury times 1 atm, that is just 50. Then 760 times this our unknown, let's represent it as x, 760 times x. So divide both sides by 760, which is disturbing our x. So 50 divided by 760, you get our value for x. So that's how you go about the conversion. We're not talking about conversion today. Let's complete what we are trying to do. Now, that is all about getting a number of mole for an ideal gas. Okay, now the last one, the last molar relationship is for elementary particles. And we all know what elementary particles are already because I've described it earlier. Elementary particles particles such as atoms, electrons, ions, protons, neutrons. So when any of them are mentioned in the equation, this is the formula for you to use. This is the formula for you to use. Now, the formula for you to use is number of moles is equals to number of the particle mentioned all over Avogadro's constant, which is 6.02 times 10 raised to power 23. So with everything I've said, we have summarized everything that has to do with the mole concept. So what remains for us to do now is to tackle calculations. That will be done in the next session. The only thing we are doing in the next session is tackling calculations related to mole concepts. Tackling calculations that deals with mole relationships. So you will see how all these formulas, you see the way they are utilized. So okay, make sure you memorize all these values. Make sure you check all these values. You read up on the things you don't understand or ask questions. And I'll always be available to guide you. So till the next video session. Thank you.